Okay, question number 6. Question number 6 says use the substitution u equals to square root of x cubed plus 1 to show that integral of 9x to the power of 5 over square root of x cubed plus 1 dx is equals to 2 times x cubed plus 1 to the power of k times x cubed minus a plus c, where a, k and the a are the constant to be found and c is the arbitrary constant. So the hint they gave us is u equals to square root of x cubed plus 1. So if I use this directly in the integral over here, so that's not going to be helpful because that's the only one is going to be replaced with the u, and there will be still 9 x to the power of 5 dx. So these two things will be in terms of x, so that's not going to be directly helpful when you just directly put it there. So what we have to do instead, so we just basically see from the integral itself we need a dx to substitute or replace it with something in terms of u, as well as we have x here that must be replaced with u. So this is going to be helpful to do them all. So the first thing that I'm going to do is I'm going to be taking the derivative of both sides. Actually, let me write this u as the x cubed plus 1 to the power of 1.5 to do the integration clearly and carefully. I'm going to be taking now the derivative of right hand side with left hand side, I mean, with respect to u, that's simply the du, and then taking the derivative of the right hand side with respect to x gives us 1/2 x cubed plus 1 to the power of let me write everything in detail as 1 minus 1/2. That's how we do the derivative of the polynomial functions, like reduce the power by 1. And remember, this is a composite function or compound function. Let's say you're going to be using the chain rule here, that is going to be multiplied by the derivative of the x cubed plus 1. Okay, so let me write this one more, 1/2 x cubed plus 1 to the power of negative half multiplied by 3x squared. That's what the derivative of x cubed plus 1 is, and dx. So I'll be replacing the dx by that. So I need to do a little bit of arrangement in this. And okay, so the one more thing that I needed, I'm going to be doing in a minute. I have to also know the x. Okay, so this is, let's say, the one I'm going to be using, and then the second I should be knowing the x. Okay, so what I'm going to be doing is taking this u equals to x cubed plus 1 and writing this as u to the power of, let's just like say in this way, like, to clear everybody, we're going to be squaring the both side, and then that gives us the u squared equals to x cubed plus 1. Then we are moving the 1 to the other side as an x cubed equals to u squared minus 1, and then finally I can say that x is going to be cube root of u squared minus 1. Okay, and then I'm going to be putting all of this instead of x instead of dx. So I need to be let's say making the dx subject here, and basically everything together there, just to simplify. But okay, let me just put this all together instead of x and dx and etc. And you're going to be seeing we still ended up with dx, but we can easily replace it with u. Okay, so now I'm just going to be writing them 9x to the power of 5 and then square root of x cubed plus 1, and there is a dx here. Okay, so the integral of 9x to the power of 5 means cube root of u squared minus 1 to the power of 5. That's what I need to write there, and that's just going to be simply u because we said that the square root of x cubed plus 1 is u on the top, and then I need to be multiplying it by the dx. So the dx, we can get it from this expression as is 1 divided by all of this du. Okay, so we are going to be have 1 divided by 1/2 and x cubed plus 1 to the power of negative 1/2, and that's multiplied by 3x squared all together, 1 divided by that, and there will be a du. Okay, so all I have to do now to convert those x's into u and then simplify, there will be a common factor to simplify, and then on and on and on and on until like I'm able to integrate, and once I'm able to integrate, I'll take the integral and then replace u's back with dx. Alright, so this one over here is going to be replaced with u. Okay, let me just start doing this. So, and 9 the cube root of u squared minus 1 to the power of 5, and that's divided by u, and that's multiplied by everything that in terms of x is going to be replaced by the u that now. That is actually, this whole expression over here is simply can be written as 2 x cubed plus 1 to the power of half, and that's multiplied by 1 over 3 x squared du. Okay, so now let's replace it. That's going to be more clear for everybody to see what I'm going to be substitute by, right? So still there's a 5 on the top, and then there is a u over here, and that's times u. So that's simply, this is square root of x cubed plus 1, and on the top we said it's u. So that means I can write this as a 2u, and then that's multiplied by 1 divided by 3. Instead of x, I'm going to be writing the cube root of u squared minus 1 all squared. So that's a nice thing to do, because I know this are going to be simplified, as well as u is going to be simplified, and 3 and 9 and etc., and that is going to give me a simple expression that I can integrate. Okay, so 9 and 3, that's the easiest thing to do now. Is let's simplify this. Okay, there's a 3, u and u, let's actually multiply that 3 by 2 already, that's 6, and the cube root of u squared minus 1 to the power of 5 divided by the cube root of u squared minus 1 squared, it simply gives us the q squared, the cube root of u squared minus 1 cube, which is the nicest thing we can ever have here after all these monsters. Then we just simply take the 6 out. We're gonna be ending up with u squared minus 1 du. Okay, all I gotta do now is to integrate this, as that's gonna be 6 multiplied by u cubed divided by 3 minus u, and there will be a plus c. So remember that the u is square root of x cubed plus 1, and this, let's say this is 6 multiplied by 1/3, and that's going to be a square root of what was that, x cubed plus 1. Let's write it as an x cubed plus 1, but remember that is cubed, and minus a square root of x cubed plus 1. Okay, so all we have to do now is we have to be write this, like this expression, just like the expression they want us to write on the top, like this one. Okay, so there's a multiplication in between, there's two expressions, there's a 2 over here, so the plus c stays there. So I forgot to write plus c here, it's always there. Okay, so I'm going to be multiplying everything by 6, that gives us 2, and I'm gonna be writing this as x cubed plus 1 to the power of 3 divided by 2 minus 6 times x cubed plus 1 to the power of 1/2 and plus c. So I'm going to be taking I am going to be taking 2 x cubed plus 1 to the power of 1 half out the bracket, so that gives me simply x cubed plus 1, and that's going to be just minus 3. Okay, so I'll just factorize this expression right here, taking the common factor out. So that's going to be 2 multiplied by x cubed plus 1 to the power of 1 half, and that's going to be an x cubed minus 2 if I just open it and simplify, and plus c. So I'm gonna go back and then compare my final answer to their answer. I don't want to, if I do in this exam, I don't want to really, let's say, lose a mark because of the form that I missed to write. Okay, so they have in the form also 2 times x cubed plus 1. I have 2 times x cubed plus 1 to the power of k. Instead of that, I have 1 half, so that matches. And x cubed minus 2, they have x cubed minus a, so that a is probably the 2, and a plus c. So that if everything is that I did on the top is correct, this form completely matches what they have, so that means this is the final answer.